repeat it. So assume that this is the DTFT of a signal. Assume that this is the DTFT of a particular signal. Okay. Now the problem is, we do all these things in a digital signal processor. We processor work out, right? So processor, it's a digital processor. It is going to deal with digital signals. So what is happening over here? You're transforming a digital signal to frequency domain. Now your spectrum is continuous waveform. So he will not be able to handle it anymore. It's like continuous wave. So to make it convenient for a processor, what you can do, make it digital again. Then we do digital active. So how can you convert this to digital? You just sample it, or to discrete. How can you discretize the signal? Sample here. Now the fact is, so this is one period, right? So in this period, I will sample my signal, sample my spectrum. Why I'm going for sampling? Because the spectrum was continuous. So my processor was not able to handle it anymore. So I'm going to sample it. So the sampled signal, let me draw it separately. Okay, this is the continuous signal. This is the sampled spectrum of DTFT. DTFT spectrum, then I have sampled it. This thing is referred as DFT. Then I will discrete Fourier transform. So what is DFT? DFT is nothing but you have to take DTFT first, then you have to go for sampling. So you will take n samples. Assume that I have n samples in this particular period. This is one period. In one period, I have n samples. Then this is referred as endpoint DFT. So if you are taking only 4 samples of this particular period, then that spectrum is referred as 4-point DFT. If you are taking 8 samples, that is referred as 8-point DFT. If you are taking say 1000 sample, you can say that it is 1000-point DFT. So you will come across a term like this always, endpoint DFT. So n implies the total number of samples in this spectrum. Hope this is clear to you. So let's directly move on to the equation. So this is the equation for endpoint DFT. How can we calculate an endpoint discrete Fourier transform? So the equation is, so what actually we're doing is you are sampling your DTFT signal. What was the equation for DTFT? DTFT will be represented as x of, you should have a comparison between these two things. Okay, DTFT was x of e power j omega. That is represented as, or that equation was given by sigma n equal to minus infinity to infinity x of n e raised to minus j omega n. Hope you remember this equation which we discussed yesterday. Now, how can you represent endpoint DFT? So, can I write it as x of e power j omega itself? X of e power j omega. That's not fair because we used this representation as it was continuous waveform. Now it is discrete, so it's not apt to represent it as x of e power j omega again. So it's to discrete, show it as discrete in frequency domain. This is capital X to represent frequency domain. Would like to show it as x of k. So x of k is equal to sigma. Now the one fact is that when you are discretizing in frequency domain, what will be the equivalent effect in time domain? See this. Discrete in one domain means periodic in other domain. So there is something equivalent to periodicity in time domain also. So now the summation limit is not from minus infinity to infinity. Now that will be restricted from 0 to n minus 1. The reason is when it is discrete in one domain, definitely it has to be periodic in other domain. So your signal was in the span minus infinity to infinity. Now it will be a periodic nature. That's why you have to represent it in 0 to n minus 1 only. Got it? Now 0 to n minus 1, what is the next term? X of n. So that will be likewise itself. Next, you have to sample. What you have sampled over here? You have sampled omega, right? You have sampled the frequency domain. So omega is 2 pi f, isn't it? So e power, you have minus j. Omega is 2 pi f. Let me do it over here. 2 pi f. The term was minus j omega n. Now you have to sample it. by a period of n. So this will be better represented as like this: e raised to minus j, mathematically modeled as 2 pi kn by capital N. So I am not having any more f axis, it's discretized, so it is k axis. So the equation will be, you have to by heart this: x of k equal to sigma n equal to 0 to n minus 1 x of n e raised to minus j 2 pi kn by capital N. So this is the equation to find an endpoint DFT. Is that clear? So let's try one example. Equation note ചെയ്യുന്നുണ്ടോ നിങ്ങൾ? Please note it in your notebook.
എന്തുകൊണ്ടാ ലിമിറ്റ് 0 to n minus 1 വന്നതെന്ന് പറഞ്ഞു?
Okay, limit 0 to n minus 1 ആവാനുള്ള reason, this was my DTFT, continuous waveform, right? What I am doing is, I am going to sample my signal. Sorry, not signal, sample your spectrum. So in the frequency domain, I am making it discrete. You started with a non-periodic signal, the spectrum was continuous. Now I am sampling it. Now the nature of my spectrum is discrete in frequency domain, right? You can say that in frequency domain, my signal is discrete. So discrete in one domain means, what will be the nature in time other domain? It will should be periodic. So previously, the signal was not periodic. Now you have to consider the signal as repeated versions. Periodicity nammaloda nature consider cheyyanam. So minus infinity to plus infinity, where in the span you may not have signal from minus infinity to infinity. Okay, you are writing from minus infinity to plus infinity, but your signal may be say 0 to 10 or 10 to 100. That will be the span. Span will be like that. Now you have to repeat that. So you have to consider only, you will represent it like this: 0 to n minus 1. It will be more clear when you see an example. Okay. നമ്മൾ ഇതിനെ ഒന്ന് ഡീറ്റെയിൽ ആയിട്ട് പിന്നീട് ഒരു സെക്ഷനിൽ നമുക്കൊന്ന് അനലൈസ് ചെയ്യേണ്ടതുണ്ട്. തൽക്കാലം ഇത്ര മനസ്സിലാക്കിയാൽ ഇത് ക്ലിയർ ആണല്ലോ. സ്പെക്ട്രം ഡിസ്ക്രീറ്റൈസ് ചെയ്തത് കൊണ്ട് ടൈം ഡൊമൈനിൽ എന്ത് ചെയ്യണം? പീരിയോഡിക് ആയിട്ട് മാറണം. ദിസ് ഇംപ്ലൈസ് ദാറ്റ് ദ സിഗ്നൽ ഈസ് നോൺ പീരിയോഡിക്. This implies that the signal is periodic. That mathematical modeling ആണ്. Equation note ചെയ്തോ? We'll do the problem right now. Make it fast. Equation note ചെയ്തോ എല്ലാവരും? So let's try one problem. Okay. So the first question is, write the question. Find the 4-point DFT of signal x of n equal to a simple problem 1100, just for practice. So signal is given to you, that's 1100. Let me try to plot it in time domain. Time domain in the plot. Okay. So this is n. So when n equal to 0, sample value is, this is x of n. Sample value is 1. Next sample value is also 1. Then for 2 and 3, the values are zeros. So it's periodic or non-periodic right now? It's a non-periodic signal, right? When you are taking DFT eduthu kadiyumbol, then you have to treat it as a periodic signal. That means it has to repeat after that. Adana nerthe nammal paranja. That's why you changed the limit. Okay, we'll analyze it in detail later. So you try to solve this problem right now. So let me write the equation. Okay, I will help you with the beginning steps. You do like this. It will be represented as, spectrum will be represented as x of k, right? So x of k is equal to sigma n equal to, you write your general equation first, x of n e raised to minus j 2 pi kn by n. You have to by heart this. First thing, you substitute the value of capital N. You always modify the equation first, then you proceed. Else in each and every step you have to do the substitution. So always it's easy to do the substitution for n first. So 0 to, in my case, n is 4 because I'm calculating 4-point DFT. So 0 to 3 x of n e raised to minus j 2 pi kn by 4. So this will get cancelled and it will become pi by 2. So now the equation is sigma n equal to 0 to 3 x of n e raised to minus j pi kn by 2. So this is the equation that you are going to use for your solution, to find your solution. Now, one thing, what you are doing is you have to see, you are sampling a DTFT signal. When you are taking n samples, your spectrum will say look like this. Here you have say 1, 2, 3, 4, 5, 6, say 7, 8. It's an 8-point DFT. First sample will be referred as x of 0, capital X. This is x of k. This is k. First sample is x of 0. Second is x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, and x of 7. Assume that this is an 8-point DFT. So the index varies from 0 to 7. In general, you can say that if you are taking an n-point DFT, the index will vary from 0 to n minus 1. So ultimately, I want a plot like this. That means I want the values of x of 0, x of 1, x of 2, and so on. In our case, you have to compute which all values? You have to find x of 0, x of 1, x of 2, and x of 3 because you are calculating n-point 4-point DFT. You are calculating a 4-point DFT. So you have to find all these values. What are these values? So let's start with x of 0. All of you do it in parallel. Book will substitute x of 0, sigma n equal to 0 to 3. It's x of n, okay, e raised to minus j pi k is 0 right now, 0 into n divided by 2. So this term will become e power 0, that is 1. So first term will be always very simple. It will be like this, x of n. Next term is 1, e power 0, that is 1. Now you substitute n 0 to 3. So this is x of 0 plus x of 1 plus x of 2 plus x of 3. This is nothing but sum of all the terms, your sequence. First term is, this is x of 0, x of 1, x of 2, and x of 3. 0, 1, 2, 3. X of 0, x of 1, x of 2, and x of 3. So you add all the terms, 1 plus 1 plus 0 plus 0. That will be 2. So later we will discuss about the properties of DFT. At that point, this is one important property. First term, x of 0 will be nothing but sum of all the terms. In time domain, you add all the terms. That's clear from this equation. Why it's happening like that? When k equal to 0, this term will definitely become 1. So what else left over here is summation of all the terms. So x of 0 will be always sum of all the terms. And in our case, that is 2. Have you done that? Proceed here.
Yes, sir.
Okay. Slow, just tell me. Okay, I will wait. Next is, ഞാൻ എല്ലാ സ്റ്റെപ്സും എഴുതിയാണ് കൂടുതലും പോകുന്നത്. അപ്പൊ നിങ്ങൾക്ക് പാരലായിട്ട് നിങ്ങൾക്ക് ഈസി ആയിട്ടുള്ള സ്റ്റെപ്സ് യു ക്യാൻ സ്കിപ്പ് ഇറ്റ്. സോ എക്സ് ഓഫ് 1, you do it. X of 1 equal to 0 to 3. X of 1, this should be capital and this should be small. Okay, this is time domain, this is frequency domain. E power minus j pi kn. K is 1, 1 into n is n divided by 2. Sorry, this is not 1, this is n, right? X of n. Now you do the substitutions. X of 0 into e power 0. Okay, so that will be x of 0 plus, substitute n equal to 1. I am changing the index 0 to 3. X of 1 into e power minus j pi by 2 because n is 1 plus x of 2 into e power minus j. Now n is equal to 2. 2 will get cancelled, minus j pi plus x of 3 into e power minus j. N is 3, so this will be 3 pi by 2 minus j 3 pi by 2. And in our case, you have to don't find all these values. Okay, The values എല്ലാം കണ്ടുപിടിക്കണമെന്നില്ല. In our case, x of 2 is 0. X of 3 is also 0. Your sequence was 1 1 0 0. So this 0 will give us some advantage in these computations. Okay. And x of 0 is 1. X of 1 is also 1. So the equation is 1 plus 1 into e power minus j pi by 2. You have to find the value of e power minus j pi by 2. So just focus over here. E raised to minus j 2 pi by 2. You can do it in two ways. E raised to minus j pi by 2 is what? Cos pi by 2 minus j sin pi by 2. So cos 90 is 0 minus j sin 90 is 1. So the answer is minus j, right? This is one option. Or you switch your you have to do scientific calculator. Okay. At the last word scientific calculator. In scientific calculator, you put your calculator to complex mode. Complex mode should be able to handle complex number. The result is a complex number. So this can be represented like this. There is an option in calculator to write like this: r angle theta form, polar form. This is referred as polar form. R angle theta form. R angle theta actually calculator, even though you are typing R angle theta, it actually implies like this: R e raised to I theta or j theta. You cannot type like this completely in calculator. So what they are using is this format: R angle theta. So what is the value which you have to find? I want the value of e raised to minus j pi by 2. So this is nothing. How will you type it in calculator? R is equal to 1. So 1 angle theta. Theta is how much? You have to take care of the sign also. Okay, minus pi by 2. Theta, this is j or I, whatever it is. So here I have j. So theta is how much? Minus pi by 2. So in calculator, you just type this: 1 angle minus pi by 2 and press the equal button. In calculator, you just type this thing and press the equal button. You can see the answer. The answer will be minus j. Do remember one more thing. Many students make a mistake over here. When you type minus pi by 2, your calculator should be in which mode? Degree or radian? Type in if you are using the notation pi, okay, pi has 3.14. So pi by 2 will be 1.732. You can either type that value 1.732 or you can use pi by 2. You have default symbol in the calculator pi, right? If you are using this thing, calculator should be in radian mode. Calculator radian mode because it's in radian. If your calculator is in degree mode, what you have to type here? 1 angle minus 90 degree. That's it. Exam okay. Calculator should be in radian mode if you are using minus pi, and it should be in degree mode if you are using, instead of pi, you can use 180. So this will be 180 by 290 minus 1 angle minus 90. If provided calculator is in degree mode. In radian mode, you have to type as 1 angle minus pi by 2 itself. So here I am substituting the value minus j. So what is the answer? 1 into minus j is minus j. So answer is 1 minus j. X of 1 will be 1 minus j. So you proceed with next two values. Find x of 2. All of you try that. You will stop with this problem. Okay. Work out. Your equation is sigma n equal to 0 to 3 x of n e power minus j when n equal to n is 2, right? Okay. When n equal to 2, 2 will get cancelled. So e raised to minus j pi. Which is nothing. 0 into e power 0, that will be 1 plus x of 1 into e power minus j, where I missed 1 n. Something happened. It's not minus j pi, it's j pi n. You have to substitute over here. You have to substitute k equal to 2. 2 will get cancelled. It will be raised to minus j pi n. So it's a raised to minus j pi n. n equal to 0, this will be x of 0. When n equal to 1, e raised to minus j pi plus x of 2 into e raised to minus j 2 pi plus x of 3 into e raised to minus j 3 pi. So the answer is x of 0. Find this value. This will be minus 1. So minus x of 1 plus x of 2 minus x of 3. So the answer will be 1 minus 1 plus 0 minus 0. That will be 0. Kitio, just respond me, please.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now let's find the last term. So last term is x of 3, right? Find the value of x of 3. X of 3 is equal to sigma n is equal to 0 to 3 x of n e raised to minus j 3 pi n by 2, isn't it? Substitute the values and find the answer. The answer, you try it. Try to do it. Give you 2 minutes to do that. Please switch on your cameras. Cameras on cheyilla. I think you can switch off the cameras. Chilarku network issues undonu thonu. Some people are getting left. Is it 1 plus j?
Yes, sir.
Okay.
Yes, sir.
So that's it. You have calculated the 4-point DFT. So at last you have to write all these things. But can you write the x of k? First term was 2. Second term was 1 minus j. Your answer should be like this. Okay, you have to specifically write like this. X of k is equal to 2 comma 1 minus j comma 0 comma 1 plus j. Got it? Now you can find 8-point DFT for the sequence also. So if you are asked to find the 8-point DFT for the sequence, what you will do? You have to increase the number of samples. Number of samples means now the sequence is 1 1 0 0, right? You add 4 zeros to this. If you are asked to find the 4-point DFT, you add 4 more zeros and 8-point DFT. You add 4 more zeros and find 8-point DFT. You can find the 8-point DFT now. That's all. Now I will give you a shortcut to find this answer in less than 1 minute. So this was my sequence, right? I want to find the DFT. This is x of n. I want to write what is x of k. So this is the shortcut. To get the first term, what was the shortcut? I already discussed it with you, right? First term എങ്ങനെ കണ്ടുപിടിക്കാം?
Sum of
all the terms. 1 plus 1 plus 0 plus 0. So that will be 2. Okay. Second term you have to work it out. Second term നമ്മൾ ചെയ്ത് കണ്ടുപിടിക്കണം. So that will get it as 1 minus j. Now the third term or specifically x of n by 2th term. We have a shortcut for this. X of n by 2th term. And in our case, that is x of 4 by 2. Okay, that is x of 2. So this is 0, x of 0, x of 1 and x of 2. To find this term, you have a shortcut. And the shortcut is, you have to give alternate plus minus term for the sign for the terms. First term should be positive. Make the second term negative. Make the third term positive. Make the fourth term negative. Even though if it minus 1 angle, you have to make it plus 1. You have to multiply with minus 1 alternatively. Got it? So this will be 1. This will be minus 1. 1 minus 1, 0. Plus 0, minus 0. If you have another term, plus next term, minus next term. Plus next term, minus next term. You have to go like that. So what will be the answer in our case? 1 minus 1, 0. Plus 0, 0. Minus 0, 0. The answer is 0. Can you tell me the reason behind this? Who is helping to do? What's the logic behind this? To find x of kth term, we were using this equation, x of n. Sigma is there, n equal to 0 to n minus 1. E raised to minus j 2 pi k n by capital N. This is n by 2th term. When it is, instead of k, when it is n by 2, it's n by 2th term, n will get cancelled, 2 and 2 will get cancelled, and the speciality of this is nothing e raised to minus j pi n. What is the value of e raised to minus j pi n? It's minus 1 raised to n. When n is 0, this will be 1. When n is 1, this will be minus 1. When n is 2, again minus 1 square, this will be 1. When n is 3, this is again minus 1. Alternate plus minus കൊടുക്കാനുള്ള reason ഈ term ആണ്. ഇതിന്റെ ബ്യൂട്ടി കാരണമാണ് നമുക്ക് ഇത് 1 minus 1, 0 minus 0 എന്ന് പറഞ്ഞ് ചെയ്യാൻ പറ്റുന്നത്. So this is possible if k is replaced with n by 2. That's why I told for the x of n by 2th term, you can apply that shortcut. Now the last term, you don't want to work it out. Last term എന്ന് പറയുന്നത് there is another format. This was the center term. നമ്മൾ ഇതിനെയാണ് center term ആയിട്ട് identify ചെയ്യുന്നത്, n by 2th term. Okay, with this center, your DSP will have a symmetric property. Because if it is 1 minus j, this will be conjugate of that. This will be 1 plus j. Always it's like that for real numbers. When your sequence is having a real numbers, this is valid. So this is your answer. 2, 1 minus j, 0, 1 plus j. This is sum of all the terms. Here, alternate plus minus. You have to do this mathematically. Take the conjugate. That will be the next term. 1 plus j. Got it?
അപ്പോ 8 ടേംസ് ഉണ്ടെങ്കിൽ സെന്റർ ടേം ഏതായിട്ട് എടുക്കും?
Okay, നമുക്ക് 8 ടേംസിന്റെ ഒരു just ഒരു എക്സാമ്പിൾ നോക്കാം. x of k. Assume that I have 8 terms. So first term will be, this is 0th term. First term x of 0. This will be sum of all digits, right? Then you have remaining how many terms? 1, 2, 3, 4, 5, 6, 7. Total 1, 2, 3, 4, 5, 6, 7, 8 terms. This is sum of all the terms. Now what will be the middle term? X of 4. Because you are calculating 8-point DFT. So x of 4 nu parayunnathu, this is x of 0, x of 1, x of 2, x of 3, and this is x of 4. X of 4. This is the center term. If this is 1 plus j, this will be 1 minus j. If it is 2 plus j, this will be 2 minus j. Symmetry will go on like this.
Okay, sir.
So you can use shortcut for these two terms. Okay, then you have to mathematically work out 1, 2, 3. These 3 terms, then conjugate it.
Okay, sir.
Okay. Now, what's the time? 10:15. Okay, let's stop. I will give you a task. You have an assignment.